Welcome to Beginner Data Mining in Python. In this lesson, we will explore how to load data, clean it, and visualize it using Python. We will use the Iris, Titanic, and Groceries datasets. Let us get started on our data adventure together. Running the cell now. Let us set up our environment so warnings do not interrupt us. We are making sure that warning messages do not distract us. Import numpy as np. We set the random seed to 42 for reproducibility. Hiding warnings helps beginners focus on what matters. Running the cell now. In this step, we've set up our Python environment for a smooth data mining experience by importing necessary libraries and suppressing warning messages. Although there's no visible output, this code ensures cleaner, more readable results as we load, clean, and visualize our datasets in the next sections. This setup helps us focus on key insights without distraction from warnings. Iris dataset, data setup. The Iris dataset contains measurements for different types of flowers. We will use it to practice data loading and exploration. Running the cell now. This code prepares the Iris data. We bring in pandas, the data tool. The data is read from a public link. Now our data is available as a table called df. Shape tells us the number of rows and columns. The first few rows give us a quick preview. Running the cell now. This output confirms the Iris dataset has 150 rows and 5 columns, including for measurement features and 1 species label. The first 3 rows show the sepal and petal dimensions for the Setosa species, illustrating how the data is structured for further analysis. This initial exploration ensures we have successfully loaded the dataset and can now begin examining its attributes in detail. What are the columns? Let us print out the list of columns to see what information we have. Running the cell now. We are listing every column name in our data. Running the cell now. Here, we printed the list of columns in the data frame to understand what data we're working with. Notice the 5 key features: sepal length and width, petal length and width, and the species label. This helps us see the structure of the dataset and plan how to analyze or model the data next. Try to match these columns to parts of a real flower. Let us check if any data is missing before moving ahead. For each column, we see how many missing entries exist. Running the cell now. This output shows the count of missing values for each column in the dataset, and as we can see, all columns have 0 missing values. This confirms that our data is complete, which is important before we proceed with any analysis or modeling. Simple descriptive statistics. Exploratory data analysis, or EDA, helps us learn about the data. Let us start with some summary statistics. Running the cell now. This summary gives us quick insight before visualizing. This command displays a statistical summary of each numerical column in the data frame, including count, mean, standard deviation, minute, max, and quartiles. Running the cell now. This output provides a quick statistical summary of each feature in the dataset, such as the mean, standard deviation, and quartiles for sepal and petal measurements. Notice the range between the minimum and maximum values, which shows the variability in the data, and the 25th, 50th, and 75th percentiles that help us understand the data distribution. This simple descriptive statistics step is crucial in EDA to get an initial sense of the dataset scale and spread before deeper analyses. Visual tools like histograms help bring numbers to life. Now let us see how petal lengths are spread out. We are importing matplotlib for visual plots. This will show a histogram with 20 sections. The chart will have a simple, clear title. The bottom labels will show units in centimeters. Side labels show how many flowers in each group. You can see if most petals are short, long, or in between. Running the cell now. This histogram shows the distribution of the petal lengths in the dataset, allowing us to see the frequency of each length range. Notice the shape and spread, which can reveal if the data is skewed or has multiple peaks. This simple visualization complements summary statistics by giving a clear, visual overview of the petal length variable's behavior. This line is a comment explaining the plot's purpose. This line draws a scatter plot using sepal length and petal length, coloring points green. This line sets the title of the plot to describe what is shown. This line labels the x-axis as sepal length in centimeters. This line labels the y-axis as petal length in centimeters. This line displays the plot so we can see it. Running the cell now. This scatter plot visually explores the relationship between sepal length and petal length in the dataset, helping us identify patterns or correlations. Notice how points are distributed across the plot. This initial step in EDA gives us insight into variables' behavior before diving into detailed statistics. The green dots represent individual measurements, showing that as sepal length increases, petal length tends to increase too, suggesting a positive trend. Next dataset, Titanic survival. The Titanic dataset helps us practice working with mixed types of data. Let us load it and get a quick first look. Running the cell now. This section sets up the data by loading the Titanic dataset. We import the pandas library for data handling. Here we specify the URL where the Titanic dataset CSV file is located. We read the CSV data from the URL into a data frame named df. We print the shape of df to see the number of rows and columns. We print the first 3 rows to preview the dataset. Running the cell now. The output shows the Titanic dataset has 891 rows and 12 columns, confirming a mix of passenger details like age, sex, ticket class, and survival status. Noticing the first few rows helps us understand the data structure and types: categorical, sex, embarked, numeric, age, fare, and identifiers, passenger ID. This initial look sets the stage for exploring patterns related to survival by these various features. Let us count how many males and females were on board. This is one way to explore group sizes in your data. Running the cell now. Here, we're using value_counts to quickly see how many males and females are in the Titanic dataset. Notice that there are significantly more males, 577, than females, 314, which is important as it sets the stage for analyzing survival rates by gender later. This helps us understand the data's composition before diving deeper. Survival rate tells us more than just numbers, it is about chance. We now check what portion of people survived. By setting normalized true, we get the survival rate as fractions. Running the cell now. This output shows the proportion of passengers who did not survive, 0, versus those who did, 1, with about 38% surviving and 62% not. Notice how the value_counts, normalize equals true method quickly summarizes the survival distribution as relative frequencies, giving us a clear first glimpse into the dataset's key outcome variable. This aligns with our goal of understanding the makeup of the Titanic data before diving deeper. Data plots give us a clearer picture than tables alone. Let us use a count plot to see how survival was different for each ticket class. Seaborne is a friendly module for data visualization. The x-axis groups people by their ticket class. Survived groups are shown with different colors. The chart title explains what we are comparing. Y-axis is the number of passengers per group. Legend tells which bars show survival or not. We can spot patterns in who survived. Running the cell now. This count plot shows the number of passengers in each class and how many survived versus did not survive. Notice that first-class passengers had a higher survival count compared to third class, indicating a trend of survival favoring higher classes. This visualization helps us understand how categorical variables like class relate to survival outcomes in the Titanic dataset. Try changing the hue to another column like sex for practice. Association rule mining, groceries dataset. This dataset tracks what shoppers buy together. Let us load it and create baskets of items for each shopper. Running the cell now. This section sets up the data for the groceries dataset. We import pandas to handle data in table form. We import KaggleHub to download datasets and OS to interact with the file system. We download the groceries dataset using KaggleHub and get its local path. We list all files in the dataset directory. We select the first CSV file found in the dataset folder. We read the CSV file into a pandas data frame for processing. We print the shape of the data frame to see the number of rows and columns. We print the first 3 rows to preview the data. Running the cell now. The output shows the dataset contains 38,765 rows and 3 columns, member_number, date, and item description. This confirms we have detailed transaction records for many shoppers, with each row representing one item bought by a member on a specific date. This sets the foundation for creating baskets of items per shopper, essential for discovering associations between products later on. One key idea: association rules reveal items that go together, like bread and butter. We want to find out which items people buy together. By grouping purchases by customer number, we make baskets of items. This count tells us how many shopping baskets we have. Let us peek at the first basket to understand its format. Running the cell now. The output shows that there are 3,898 distinct baskets, each representing a unique shopper's collection of purchased items. Notice the example basket lists several items, including repeated sausage, which reflects multiple quantities bought by the same customer. This setup is crucial for association rule mining, as it organizes the data into transactions for discovering item co-occurrence patterns. Check the most common items by changing transactions as 0. Recap: you did it! You have learned how to load, clean, and explore 3 popular datasets. We covered summary stats, visualizations, and set the stage for more complex analysis. Keep practicing these basics, they are your foundation in data mining. Running the cell now. Keep learning and subscribe. If you found this lesson helpful, please like and subscribe for more beginner-friendly data science tutorials. Try rerunning parts of the code with your own changes to deepen your understanding. Running the cell now. Practice, find another dataset and try basic EDA steps outlined here.